Greetings, students. Today we will be discussing questions 26 through 50 on our final exam for semester 1. So, question 26. Use the proof below, fill in the reasons. So, starting off with reasons 1, AB is congruent to FD because it was given. Angle A is congruent to angle D, also was a given in the original. And angle F is congruent to angle B, well, that was also a given. These three statements were given. Now, I'm not asking you about the first 3 reasons here. I'm asking you about reason 5. But it's important you understand the entire flow of the proof. So it's important you do all of the reasons here, because I might not ask you on the test for step 5. I might ask you for step 4 or 3 or 2 or 1. All right, next thing. Triangle ABC is congruent to triangle DEFY. Well, let's mark up what I have here on my first 3 statements. I have AB, I'll use a slash, congruent to FD. So side 1 is FD and AB. I have angle A, so I use 2 arcs here because it's angle 2 now because it doesn't correspond to side 1. So angle A congruent to angle D. So this is angle 2 corresponding together. And then I also have angle F congruent to angle B. So angle F, I'll use 3, congruent to angle B. So now I'm looking at this for the type of congruence used. I've got a side sandwiched in between 2 angles here. So this is angle side angle congruence. Again, on this practice version, I'm not asking you for the 4th reason here, but on the test I may ask you for the 4th reason, and you would state it's angle side angle congruence. And it's definitely not side angle side congruence. So this is corresponding parts of congruent triangles. The parts of a triangle are congruent once you've shown they're congruent with a congruent statement. One of the statements, side angle side angle angle, or angle side angle, or the hypotenuse leg theorem. Again, you need to fill in the entire proof here, and then you can figure out what the statement is that I'm asking for. I'm asking for statement 5 here. So be prepared on the test to fill in this entire proof. All right, question 27. Given that the 2 triangles are congruent, what is the value of ln? Ln is a side length. Angle D and angle L are actually, these are angles. DF is a side length as well. So DF should be corresponding to ln, and it is. They're the same length. However, I need to solve for x first using these 2 angles. Angle D is congruent to angle L because they're in the same location of the congruence statement. So I will start off this question by setting 5x minus 10 equal to 4x plus 10. Taking 4 from 5 yields x. Adding 10 to 10 yields 20. Once I've found the value of x here as 20, I will resubstitute that in to the length here df, because df is congruent to ln. So the length df should be equal to 3 times 20 plus 5. Well, 3 times 25 is 75 in length. Question 28. This is an isosceles triangle, meaning that the base angles are congruent. So angle F and angle G are the same measurement, and the angles all add to 180 because of the triangle sum theorem. I will start off this question by subtracting 130 from 180 to get what amount remains for the 2 given angles. So there are 50 degrees left over in the triangle, and each of those 2 angles must be the same value, angle F and angle G. So they must both be 25, since the triangle is isosceles. All right, question 29, the third side theorem. The 2 sides of a triangle will be greater in length than the third side. So when I add them together. So when I add 6 and 10, I get 16. The third side must be less than 16. And it also must be greater than the difference between the 2 given sides as well. Notice here I switched the 10 and the 6 because the side length cannot be negative, so I subtracted 10 and 6 here, and I got positive 4, not negative 4. So between 4 and 16 is what the third side must be. Bigger than 4, less than 16. Question 30, the distance formula. We're looking for the distance between A and C. So I'll have D is equal to the square root. Again, this is the length in the x squared plus the length in the y squared. So the x is decreasing in value by 10, so this will be negative 10 quantity squared. The y is increasing in value by 9. From negative 4 to 5 is 9, so plus 9 squared. A negative quantity squared is positive, so this will be 100 plus 9, 81, because 9 squared is 81. So this will be the square root of 181. When you're doing this question, the negative quantity squared is always positive. In our class, geometry, we will not have this ever be a negative value inside of a root here like this, because we are not working with complex numbers. So when you're thinking that negative squared is negative, it's not going to apply to geometry. It does apply in Algebra 2, but that again is for an application using complex numbers, not using what we're doing here in geometry. The distance between 2 points will always add, in other words, here in the middle, for geometry. Alright, question 31. Triangle ABC. I don't know what the format for triangle ABC is, but I do know that it's close to equilateral because the angles are very close to 60. In fact, angle B is exactly 60. So I will draw this to look like an equilateral triangle. Angle A is 65. I need to find the value of angle C here before I can decide which side length is the longest. So I will add 60 and 65 and subtract that value from 180 to get the value of angle C. So 180 minus 125 is 55 degrees. The shortest side on a triangle corresponds to the smallest angle. So the shortest side on triangle ABC here should correspond to angle C. And angle C corresponds to side AB because it doesn't contain the letters A and B. So AB is the shortest side, followed by AC, which is corresponding with angle B, followed by BC, which corresponds with angle A. So the side lengths in order from smallest to greatest, or from least to greatest, shortest to longest, is AB, AC, and BC. Solve for the missing angle, and then the shortest side corresponds to the smallest angle of any triangle. Question 32, which of the lengths form a triangle? Right at the start of this question, look at letter A. If all the sides are the same on a triangle, what is that called? Equilateral. So letter A is the proper response here. Equilateral triangles have congruent sides. Now why are B, C, and D not triangles? Well, with letter B and C here, when I add the two given sides, the shorter sides, they are less in value than the third side. The hypotenuse is not a hypotenuse unless it's a right triangle. But the two smaller sides are less in value than the third side theorem in this case. That is not a triangle when that happens. Same thing on letter C. When I add 3 and 4, that is less than 11. The two sides must be greater than the third side. And D is not a triangle because the two sides, when they add together here, equal 10. Again, this must be greater in value, the two shorter sides, than the third side. Now, when you're doing this question, the sides might not necessarily be in order from smallest to greatest. We're taking the shorter sides and adding them together and comparing that value to the largest side. So make sure you have them in order from smallest to greatest, or remember to use the shortest sides when you're adding here. All right, question 33. Median. Median is cutting a segment length in half. So BE is a median of triangle ABC. It cuts side length AC in half. So I will take this 6, and it is the same length from E to C, 6 and 6. So the entire length from A to C is AE plus EC because of the segment addition postulate. 6 and 6 makes 12, in other words. The side length is 12. All right, moving along, question 34. ABC is a right triangle. What is the length of the midsegment, DE? Midsegment again cuts a segment in half. It would be nice if AC was labeled, and it may be labeled on your test. So if this length was labeled for you, you would take half of AC and it would be equal to DE. However, it's not labeled here. So in order to do this question, I have to do some setup. I have to find the length AC using the concept of right triangle. A right triangle, the hypotenuse across from the largest angle, the 90-degree angle, is the square root of the sum of the squares of the other two sides. So we'll use a squared plus b squared equals c squared, or in other words, c squared equals a squared plus b squared, to find the missing side, AC, before I can cut it in half. So AC squared will equal in value to 5 squared plus 12 squared. 5 squared is 25, 12 squared is 144. So AC squared is equal to 169, 25 plus 144. The square root of 169 is 13. This is the entire length from A to C. I'm looking for the mid segment, so I'm going to cut this length in half. My answer is 6.5 or 6 1/2. Again, on the test, it may in fact be labeled the side length, and you'll just have to cut it in half to get the mid segment. If it's not labeled, if you have to find the missing side with the Pythagorean theorem, work the Pythagorean theorem. And again, you're adding the sides together if you're looking for the hypotenuse of the right triangle. You're squaring and adding them. If you're looking for a leg, you're subtracting on a right triangle. All right, question 35. The concurrencies of a triangle. There is an acronym to help you remember this, PAMACICO, P-A-M-A-C-A-C-I-C-O, P-A-M-A-C-I-C-O. So, if I'm looking at P, which is the perpendicular bisector, then I'm looking at the circumcenter. So I'm not looking at perpendicular bisectors here. I'm looking at medians. So this is not the circumcenter. If I'm looking at A, which is angle bisector, I'm looking at incenter. Well, I'm not looking at angle bisector. I'm looking at medians here. So this is not incenter. If I'm looking at medians, oh, well, that's what I'm looking at, medians. So what is this one? Well, this is centroid. Centroid. This is actually the one we've practiced the most on the test, the centroid. Remember, the centroid is 2/3 of the way through the triangle. And then the last one here, altitudes and orthocenter. I might not be testing on the final exam for the median. It might be one of the other keywords, perpendicular bisector, angle bisector, altitude on a triangle. That acronym can help you remember it. You can also be helped to remember it by drawing a circumcenter and the incenter with the circles. Remember, the circumcenter is a circle around the triangle, and the incenter is a circle inside the triangle. That may also help you remember it somewhat. All right, question 36. Dodecagon. How many sides? Do. So dodecagon. Decagon is 10. Dodecagon is 12. 2 plus 10. Kind of like dos plus diez. Dodecagon. Polygons. Polygons cannot have curves. So right here, this tells me option D is not a polygon. Polygons cannot have, option A is also not a polygon, intersections between the sides. So that tells me option B is not a polygon, because this one right here in the middle, that is not a polygon. So option C is all polygons. The sides have to be straight. They have to connect together. And they cannot have curves. All right. Question 38. The sum of the interior measures of a decagon. So that's 10 sides. 10 sides. Decagon. So a triangle is 180. A rectangle, square, quadrilateral, four-sided shape is 360. It increases by 180 each time after 3 sides. So you can either do this as a pattern by adding 180 each time. So in other words, the pentagon's 540, hexagon is 720. Or you can use a formula here. The formula is 180 times the number of sides minus 2. Now if you forget the formula, again, use the pattern. 180 times 8, not 6, and minus 2. Use the pattern. So again, triangle's 180, quadrilateral's 360, pentagon's 540, it's adding 180 each time. The formula will give you the answer quicker, however. So 800 plus 640 is 1440. Or you can also think of that as 180 times 10 subtracting 360, if you want to think of it that way as well. You can multiply by 180 and then subtract 360 from that. So 1800 minus 360, in other words, would also be an appropriate way to think of this one. All right, question 39. Given that the exterior angle of a regular polygon is 36 degrees, determine the number of sides. The exterior angles on any polygon will add to 360. So I can take 360 and divide by any exterior angle to get the number of sides. 360 divided by 36 is 10. This is a decagon. Now, if that wasn't 36, say for example if it was 60, then this would be a hexagon. 360 divided by 60 is 6. What would it have to be a pentagon? 360 divided by what is 5? Well, that angle is 32, or 72. 72 degrees for it to be a pentagon, for it to be 5. For it to have 18 sides, well, 360 divided by 18 would be 20. Exterior angle of 20 degrees. Anyways, 360 divided by the number of sides will yield the exterior angle of a polygon, or 360 divided by the angle, the exterior angle, will yield the number of sides. You can do it either way, back and forth. All right, rhombus. On a rhombus, also on a square, because the diagonals are perpendicular and bisected, and because all the sides are the same length, the angles are bisected as well. So what I know here on this rhombus is that the angle ABC is in fact 50 degrees. Now that does not give me the angle BAC, but it does give me the angle ABC, 25 plus 25, because it's been bisected. The angle BAD will be the supplement of that, because the consecutive angles are supplementary on any parallelogram. So angle BAD is 130, 180 minus 50. And I'm asking for half of that angle. Angle BAC is 65. Half of 130 is 65. So here again, I'm looking at this rhombus. The angles have been bisected because it's congruent sides and the angles are perpendicular. All right, next one. What is the measure of each exterior angle? Each exterior angle, so individually, each angle, not all together. All together they add to 360 always, of a regular pentagon. So I will take 360, I will divide it by 5. This will yield the measure of an exterior angle on a pentagon, which we already discussed on question 39, 72 degrees. The exterior angles of any polygon add to 360. Now the interior angle sum is always different. It increases by 180 each time. But the exterior angle sum is always the same, 360 degrees. Alright, question 42. Which statement is true? This is corresponding to the statements about parallelograms. In this case, it's all about rhombi. However, on the final exam, it may be about a parallelogram, a trapezoid, a square, a rectangle. So a rhombi, does it have congruent diagonals? No. From corner to corner is different lengths. You can look at the rhombus over here on question 40. From B to D is different in length from A to C. The diagonals are different in length. That is a false statement. The shapes with congruent diagonals are the rectangle, the isosceles trapezoid, and the square. Only one pair of parallel sides. Well, that applies only to the trapezoid, with only one pair. All of the parallelograms have two pairs of parallel sides. So B is incorrect as well. Perpendicular diagonals. This is the true statement here. A rhombus, as well as a square, have perpendicular diagonals. Diagonals that intersect in the middle here, AC and BD, at a 90-degree angle. And the last statement here, on a rhombus, the angles are not 90 degrees. Only on a rectangle and square are all the angles 90 degrees. All right, question 43 is similar in nature here. We're talking about rectangles now. So adjacent sides are not congruent on a rectangle. That's a true statement. The adjacent sides are not true on a rectangle. However, if that rectangle is a square, they would be congruent. So it says all rectangles. Squares are in fact a subset of rectangles. So I'm going to continue down the rest of these and make sure that one of these other ones doesn't seem to match. Diagonals perpendicular, yeah, rectangles do not have perpendicular diagonals. They have diagonals that intersect at angles beside 90. They're trapezoid. Now rectangles are not trapezoids because they don't have only one set of congruent sides, so that's not a true statement. Equiangular. They do have congruent angles, rectangles. All the angles on rectangles are 90. Option D is the proper response here. Now again, option A was put first here, trying to confuse you a little bit, saying adjacent sides are not congruent. That would apply if that rectangle was a square. And a square is a subset of a rectangle. Alright, question 44. Which statement must be true? So let's go through these statements one at a time. The angle that's 30 is angle B and angle Y on this diagram. Angle X is not 30 unless this triangle is isosceles. So let's find the missing angle. 100 plus 30 is 130. The missing angle is 50 on these triangles. The angle X is 50, not 30. XZ is 5. So XZ corresponds in length to AC. What is AC? Well, AC is 5. So yes, XC should be 5. This is the proper response. What about XZ? XZ is 7. Well, no. XZ should not be 7 because XZ corresponds to AC. So the length that corresponds to 7 here should be AB and XY. XY is 7. And on this diagram, there is no length of 12 centimeters. The 12 centimeters is a distracting answer. They got that by adding the two sides together, which would not be the proper thing to do. All right, question 45. The angles on a parallelogram, adjacent angles, consecutive angles actually, same side interior, are supplementary. So 2x plus x minus 15 is equal in value to 180 degrees. This again applies to all parallelograms. The adjacent angles or consecutive angles are supplementary. So 3x minus 15 should be equal to 180. 3x is equal to 195. 195 divided by 3 is going to yield my answer, which is 65 degrees. All right, question 46. As I talked about in class, for those of you that have me, I prefer to use the exterior angle to find the number of sides, not the interior angle. The exterior and the interior angle are supplementary. So I prefer on this question to convert this 120 degree interior angle into an exterior angle before I find the number of sides. So 180 minus 120, this will yield the value of the exterior angle, which is 60. And then I can just divide that into 360 to get the number of sides, because the exterior angles always add to 360. It's always the same sum. Now that doesn't mean you have to do it this way. Again, the other approach here is to use the interior angle sum to figure out the number of sides. This is just my preferred method. Find the exterior angle, and it's always equal to 360, the sum of the exterior angles. So in this case, it has to have 6 sides. All right, question 47. The angle sum of any quadrilateral is 360. So inside this diagram, there's a quadrilateral with angles of 120, 65, and 70 labeled. So I will add those 3 angles together. And that will equal 255 degrees. When I add that with x, it should equal in value to 360. So 255 from 360, subtracted from 360, is 105 degrees. The missing angle is 105 degrees. Again, the diagrams are not necessarily to scale, but it looks like the angle x is obtuse on this diagram, so it's a good option. So it's a good guess that it would be obtuse, the answer, although the diagrams aren't necessarily all to scale on the exam. All right, question 48. Given isosceles triangle, FGH, where G is an obtuse angle, which could be the measurement of angle F? Obtuse meaning it's between 90 and 180, angle G. So if angle G is obtuse, that would leave me less than 90 degrees left over to work with for angle F and angle H. So in other words, angle F plus angle H has to be less than 90. I don't know what the value is, but I know that they add to be something smaller than 90 degrees. If the triangle is isosceles, it means they're the same value. So if F and H are the same value, well, 55 and 55 is 110. That's bigger than 90 in value. 88 and 88, 176, 111 and 111, 222. The only option here that works is option A. The two angles have to be less than 90 when they add together here because angle G is obtuse. Angle G is bigger than 90. All right, question 49, patterns. This pattern is increasing in value by 1 each time in the top of the table. So it's going by 1s here. We'll call these the x's. So x is adding 1 each time, plus 1, plus 1, plus 1. So the next value here for x would be 5. And y is adding 4 each time. 1, 5, 9, 13, plus 4, plus 4, plus 4. So we're adding 4 each time in the y's, and adding 1 each time in the x's. So what would be my equation? Well, let's consider option A, n plus 4. So if x is 1, is y 1 plus 4? Well, 1 plus 4 would be 5. No, 1 and 5 doesn't match. Let's go with option B then. If x is 1, this would be 3 minus 2, which is 1. If x is 2, this would be 6 minus 2. Well, y should be 4, not y should be 5, not 4. And 6 minus 2 is 4. So that's not correct. Option C. 4 times 1 is 1. So if x is 1, well, y should be 1, not 4. Option D. If x is 1, y is 1. Because 4 times 1 is 4, minus 3 is 1. And if x is 2, 4 times 2 is 8, minus 3 is 5. If x is 3, 4 times 3 is 12, minus 3 is 9. Now this adding 4 each time in the pattern is a slope. And to get the y-intercept, this negative 3 here, you're going to have to subtract the corresponding value to get the x to start, to get the y to start correctly. So the plus 4 tells us it's 4n. And the minus 3 comes from we need the first value to be a 1. The first output in this table to be a 1. So 4n minus 3 is my pattern. All right, question 50, inductive reasoning. Now again, this could be deductive reasoning on the final exam. Here it's inductive. It's asking you to continue the pattern. So Tina's eating peanut butter sandwiches every day, it appears. So it makes logical sense that she's going to have peanut butter sandwich on Thursday as well. That's using inductive reasoning patterns. If it was a deductive type pattern, it would be using facts or laws. Anyways, so that concludes our review for the final exam. Good luck on the test. I hope you all do well.